Okay, so let's start with next topic. Let us get into some advanced IP addressing called subnetting concepts. So in general, subnetting is the process of dividing a large network into smaller networks. Now, in simple, we are just converting your host bits into network bits, and subnetting helps in minimizing the wastage of IP addresses. So let's try to make some scenario to understand uh, how it is going to exactly make the difference. In general, in our basic IP addressing classes, we have seen we got three classes which we use in our LAN and WAN. We got ABC classes, and one C class network supports 256 addresses in one network. Anyway, we cannot use two addresses for network ID in a broadcast ID, but total there are 256 addresses. And similar way, a B class network supports 65,536 addresses, and A class supports more than 16 million addresses. So when you talk about default network size, these are all default networks and they have the default network size. So which is very big in general. We can say this default network size is very big when you compare with other requirements. Like let's take an example. In my company, I have some 4 departments: accounts, marketing, and I got sales, and I got a HR department. And each and every department I got some 50 users in my department. So total it becomes 200. So my manager says, so I'm the administrator, so my manager says that okay, all the 4 departments should be from the same network, and same network means I can use any one network. So 200 is the total size of the network, which means if I use any C class address, it will satisfy my requirement, right? Because a C class network supports 256 addresses. If I subtract -2, maximum I can connect 254 devices. Anyway, my requirement is much lesser than 254. So probably I can go with any C class address. If you want, you can use B class, A class also. But I want to go with the smallest size. In my case, C class is enough. So probably I'll use one C class network. So let's say I'm using 192.168.1. network for the complete users. So 192.168.1.1, 1.2, 1.3, 1.50 up to here. 1.51 to 100, maybe from 100 to 150 I use here, 150 to 200 I'll use here. So still I can use 50 more devices in the future if I add. But now, after a few days, maybe my manager or my administrator says that, okay, we don't want them to be in the same network because some of the sales users are trying to access accounts information. Some of the HR people are trying to access some marketing information. So there is some problem because as they are on the same network, so it's going to affect. So they said, so my manager wants me to redesign my network and make sure that all the 4 departments should be from different networks so that they should not communicate with each other. So they should not communicate with each other. So each and every network requirement is 50. So if I go with the smallest possible size, if I want, I can use B class. I can use A class also, but the smallest possible size is 256. So which means if I use the smallest possible size, so I'll use 192.168.1. network here, and different networks, which means I had to use another network here, and I had to use another network here. So I'm just trying to use only C class networks and 192.168.4. network here. So I'm going to use 192.168.1. network, 2. network, 3. network, and 4. network. And each and every department, as they are in different networks, we already learned that. So C class contains 3 network portions. If these 3 portions are different, then probably they will be considered as different networks, and they will never communicate with each other unless and until you do some routing configurations. So as of now, there is no routing. So these 4 departments will not be able to communicate with each other. So my condition, my requirement has been satisfied. That what is my requirement? I want all the 4 departments should be in different networks, and so that they should not communicate. So I did that. So we got our requirement fulfilled, but at the same time we are actually wasting a lot of IPs. If you just take this example, I'm using a C class network. A C class network supports 256 addresses. In that, I'm just using only 50 hosts, which means around 206 addresses I'm simply wasting. Similar way, if I take the second requirement also same, the third is also same, and the fourth is also same. So which means if I just calculate each and every department, so I'm wasting more than 800 plus addresses. So simply there are more than 800 addresses plus addresses are simply wasted, not much used. So the first drawback with the default network size is there's a lot of wastage. The wastage of IPs is very huge. So now you can even say I don't really bother because I'm using private IP addresses. I don't really need to bother because they are free of cost. So probably I can say that also. I don't really bother much. But still, in case if you're working for a service provider, let's take one more scenario. So I'm going to take one more scenario to trying to understand what generally we have a problems with the default networks and what is the solution. The solution is subnetting, but first we need to understand what is the problem with the default networks and why we need to do subnetting. So let's take an example. I'm an ISP, so let's say I'm working for some service provider. So service provider gets some public IPs from INA, Internet Assigned Number Authority. So INA is responsible for authorized government agency who is responsible allocation of public IPs. So probably from INA, my ISP1 let's say, purchase some network. Let's say I'm using 200.1.1 network. It's a C-class network, which means it supports 256 addresses. And I also purchased another network. So I got another network, 256 addresses. So similar way I got another network. So let's say I got 3 networks which belongs to C class, and I took some 3 networks so that I can provide a service to my customers. So now there is a customer called ABC. Let's say customer comes to you and he says, I need 10 public IPs. How many public IPs are required? I need 10 public IPs. Similar way, some other customer, let's say customer XYZ, comes to you and says he need 20 public IPs. Maybe it's a big size company, and customer, let's say PQR, comes to you and he says he just need only 2 public IPs. So now every customer may have a different network requirement or public IP requirement, because nowadays we don't need many public IPs. One public IP for hosting my probably my FTP server, for maybe my HTTP server, and one public IP for accessing internet. So probably not more than 3 to 4 public IPs, but still, let's take an example. You have a requirement like this. So now ISP already got some public IPs from INA. So now the question is, so ISP got the smallest possible size. And what is the smallest possible size here? It's 256. So now ISP cannot say that I cannot provide 10 public IPs. If you want 256, then I can provide. So that is something which is not possible. So you cannot say that. So, but again, the question is, the customer also will not pay for all 256 addresses. So it's not possible in general, because but I'm just going with the smallest possible size. So I'm using the smallest possible size, which is a C class, as per our networks. So now to meet these small requirements, so I cannot allocate the complete network to this customer, and even the customer will not pay for all 256 addresses. Both options are not possible. So to overcome this, what we can do is we can divide the default networks into subnetworks, some small networks. And this process of dividing the default networks into small networks we call as subnetting. So in simple, I can say subnetting is a process of dividing a default network. Maybe it is 256, maybe the size, or maybe B class, maybe A class, whatever the size. We have further divided into some small networks. And this process of dividing is called subnetting. And the main reason for doing the subnetting is to minimize the wastage of IPs. To minimize the wastage of IPs. Because if you see this example here, I'm using 4 different networks here. Instead of using 4 different networks, you can use only one network. What is the size of network? C class, 256 addresses. And I can divide them into 4 parts. I can use one small part for accounts, one for marketing, one for sales, one for HR. So that is what the main concept of subnetting. So in today's production networks, we'll always see subnetworks. So probably you don't find default networks. Very rarely you'll find the default networks. In most of the today's production networks, you'll find all the networks are divided into subnetworks. So that's what exactly we do here. We are dividing one default network into multiple small networks. Okay, that's what this explanation of these points tells. It divides its process of dividing a single network into multiple small networks. We'll see converting the bits, how to do that. Probably that is what we are going to do. So it minimizes the wastage of IP addresses. So some few examples, two examples. One example, a company production network, this one, and even if you take an example of service provider. So these two examples will clearly give some idea on why we need to do subnetting. What is the reason behind doing the subnetting? Subnetting is also one of the reasons to overcome, to extend your IP version 4. Okay, so now we got some idea on why we need to do subnetting. What's the reason behind that? Now the next thing, we need to know the process. Let us try to add some few more points about subnetting. So subnetting is simple. It is dividing the default network into small networks. Now the main reason is to minimize the wastage of IPs. That's okay. Now there are two methods of doing subnetting. The first method is FLSM and the second method is VLSM. So this is your FLSM method. So where we are dividing the network into equal sizes. You can see I'm dividing all the networks in equal sizes. Maybe the size of each network is 64 or maybe the size of the network is 32, whatever. But mostly equal sizes, we can say. So whereas VLSM is the same network, we are dividing into variable sizes. You can see one network may be the size of 128, other network may be the size of 64, the other network may be size of 32, and the other network may be size of 16, 16, 8, 4, like this. So it's variable. So you may not have the same network sizes. Maybe it can be same, but mostly it may not be same. Just like you have a kitchen, bathroom, hall, bedroom, where in our homes. So everything is variable depending upon the requirement. We may have two bedrooms with the same, almost same sizes, right? As per the requirement. So most commonly we use VLSM is the one which is most commonly used, variable in subnet mask. But still, first we need to understand FLSM before we get into the VLSM, because FLSM is something like foundation, I can say. So once you understand FLSM, probably you'll get a more clear understanding on VLSM as well. So if you understand FLSM, fixed length subnet mask, probably you know 70 to 80% of VLSM as well, because the entire calculation process goes similar. Okay. So two methods of doing subnetting, FLSM and VLSM. Fine. The next thing, what exactly we do in subnetting now. Now, whatever we do, so here we are saying we are dividing the network. Now, division of your network, it's always based on the requirement. So now we need to understand the requirement. What is requirement? Just like if you want to divide a big hall into some small cabins, probably you need to know what is the requirement, how many people should sit in a one classroom. If I want to make a classroom, so I can consider that how many people should sit in one classroom, or even I can say I don't really bother how many people sits, but I just need 4 rooms. So similar way here, the requirement can be the host, which is most common, and the requirement can be the networks. The requirement can be the host, can be the networks. In case if you are doing calculation, host means, if I take an example of host means how many users I want to connect in one department, like accounts users. I'm going to create a accounts department, and in that department how many users I have? 50 users, 70 users, 100 users. How many devices I'm going to connect in that particular department? Or I can just divide based on the network requirement, where I can say, okay, I don't really bother how many users, but I just want to divide a C class or B class network into 4 or 5 networks like this. Most commonly we use host requirement, and if you're calculating according to the host requirement, we need to use this formula, 2 to the power of h greater than or equal to requirement, and this formula will help us in our calculations. And then 2 to the power of n greater than or equal to requirement. If you are calculating according to the network requirement, so you have to use this formula. So here H stands for host bits and N stands for network bits. So in simple, H stands for host bits, N stands for network bits. So you'll get some more clear understanding in general when we start the initial calculations, because subnetting is something, it's more about a calculation process. First we need to understand everything about the subnetting. So now, okay, we got some basic idea on what are the formulas we use. Now finally, what exactly we do in our subnetting. So before we start our calculations, we should have a very clear understanding on what exactly we are doing. I know that we are dividing a big network into small networks as per definition, but practically what we are doing in general. So technical wise we are dividing, definition wise theoretically we are saying we are dividing, but what exactly we do in a practical wise. So practical wise what we are doing is we are just converting the host bits into network bits. And some people say we are borrowing the bits from host, or I prefer to say I'm converting some of the host bits into network bits. Or we can say we are converting our zeros to ones. If you remember, 0 represents host, 1 represents network. So let me give some idea on this. Let's take an example. Not exact example, you can say A class, B class, C class. So you already learned some basic IP addressing in the basic IP addressing, that A class by default will have 1 network portion and 3 host portions. And B class contains 2 network portions and 2 host portions, and C class contains 3 network portions and 1 host portion. So if I write this in terms of binary bits, each portion represents 8 bits. So each portion is going to represent 8 bits. So if I write this in terms of network bits and host bits, because whatever the calculation we are going to do, it's all in the form of binary digits. It's all in the form of binary digits. So probably A class contains 1 network portion, which means 8 network bits, and 24 host bits. So 3 host portions, which means each portion represents 8 bits, so it's going to be 24. So B class contains 2 network portions, means 16 network and 16 host. And C class contains 3 network portions, which means 24 network bits and 8 host bits. Entire subnetting calculation revolves around this table. So it's very important to have a very good understanding on how many default network bits we have in A class, B class, C class, and how many default host bits we have in A class, B class, C class. So from this table, we can extract one example. We can say, let's say, I'm going to take one example to understand what exactly we do in the subnetting is. If I take a simple C class example, by default, C class contains 24 network bits, 8 host bits. But after doing subnetting, we did not start doing subnetting, but probably we'll do that. But I just want to give some very good idea what happens once we do subnetting. So your host bits gets converted to network bits. That's what we just discussed. So probably after doing subnetting, this 24/8 becomes 26/6. Maybe it becomes 27/5, or maybe it becomes 30/2, or maybe it becomes 28/4. 28/4 means 24 network bits, 28 network bits, and 4 host bits. So what is exactly happening here is some of your host bits. Now in this case, by default there are 24, by default there are 8. Now here 2 bits gets converted here. Means the remaining 2. Anyway, finally total will be exact 32. That will not change. That will never change. Total bits will be always change, but some of the host bits convert into network bits. You can see by default there are 24, 3 gets converted. So here 6 gets converted, and here 4 gets converted. So in our subnetting calculations, if you want to reduce the size of the network, finally the last point, if you want to reduce the size of the network, what's the default size? Default, there are 24 network bits. there are 24 network bits and 8 host bits. So the size of the host bits, how many? 8. So what is the size of the network? 2 to the power of 8, how much? 256 is the size. That is the default size of the network. So to reduce the size of the network, we need to reduce the number of host bits. So if I just make it 6, 2 to the power of 6, how much it becomes? 64, which means the network size becomes 64. And what about the remaining 2 bits? Remaining bits we are converting into network. Same thing. So in our subnetting, we are just minimizing the number of host bits, reducing the number of host bits. From 8, I'm reducing to 6, maybe 5, maybe 2, maybe 4, depending upon the requirement. So now it depends upon the requirement. I cannot say exactly. So we are just dividing the default network sizes into multiple small networks as per the requirement. So depending upon the requirement, it can become anything. So in subnetting, in simple, we are just converting some 0 bits to 1 bits. Or we can say we are minimizing the number of host bits to reduce the size of the network. Networks, when you reduce the bits, automatically network size also minimizes. So that's what exactly we do here. So this overview will give some more clear idea when we get into calculations. So it's good to know what exactly happens when we do subnetting. So once you are clear with this point, so probably we can move on with our first example. So we are ready to start with our first example, where we'll see a step-by-step calculation process, which will give some more clear idea how the process or how the calculation goes. Okay.